Hello. Today we're going to talk about solving and graphing quadratic inequalities. So an inequality is the same thing as a quadratic equation. It just has a less than or greater than sign instead of an equal sign. Okay, so if I have a less than or greater than sign, I'm going to treat it just like an equal sign. In other words, I'm going to go through and I'm going to graph like I normally would, which would be, first of all, use x equals negative b over 2a and find my vertex. Plugging it back into my equation, I'm going to make a table, putting that vertex as the first point. And then I'm going to pick other points, plug those into the equations, find those points. And then with the axis of symmetry, I'm going to reflect them over, and I'm going to find where my parabola is. Now, here's where it gets different. Instead of just going and drawing your line, that's kind of automatic because it's the last step, and you're like, hey, I'm done. You got to wait and pause. Does my inequality symbol have an equal bar? In other words, every dot on this line, does it make the equation true? An equal bar makes everything true. And so if it has that equal bar, then you're going to have this solid line on your parabola. So step one, that's what you're looking for. You're looking for, is there an equal bar down below here? If not, then you're going to make it a dotted line. And a dotted line says everything right up to that point, but not including the line. Those points won't make the equation true, but anything on one side or the other will. So step one, do you have a solid or dotted line? Do you have an equal bar below it, or do you not have an equal bar below your less than or greater than sign? Step two, next you're looking for a test point, okay? Pick a point. Now this is where it's important. This point cannot be on the line, otherwise, what side do you graph? So you need to find something either inside or outside, any point somewhere else. Now my favorite point is this point right here. It's 0, 0. 0, 0 definitely is the easiest, fastest point to check to see if it works. Because if you put in a 0 in the x squared and a 0 in the x, you know, 0 is 0, whether you square it, whether you times it by an a, whether you times it by a b, those are all 0. So really, it's going to come right down to it. Is 0 for the y going to be less than or equal to c? That's going to help you out a lot. Makes things speed along. Now, if your graph goes through 0, 0, you can't use my favorite point. You'll have to pick something else. That's okay. But the idea is the same. Now, if you get a true statement, then you will shade that point. So if 0, 0 works and gives you a true statement, you're going to shade on the outside. Now, if you pick a point inside and you shade on the outside, then the point inside the parabola should give you a false statement. If you end up getting a false statement, you'll end up shading the other side. So you're either going to shade inside the parabola or all the way around the outside. And so if your test point is a solution and it makes a true statement, you shade wherever that point is. That's why it's important to know where your point is. If it gives you a false statement, if I test the point way out here and it's false, I'm not shading it, okay? So testing. So that should be pretty standard because we've graphed linear equations before. We've graphed linear inequalities, and basically the steps are the same. Okay, what happens if it's not a two-dimensional? In other words, what if there's no y? What if I have an ax squared plus bx plus c, and it's not less than y, but it's less than 0? Well, if you graph it and solve by graphing, you'll still get it, but your answer is only going to be on this one dimension. And so you're going to have possibly two values, and it'll either be the solution of all the points in between them, or it'll be the points on the outsides of that parabola, all the way on the inside or the outside. So it's either inside those 2 points or outside those 2 points. Because if they don't give you a y, they give you a 0 instead, you don't have that other dimension. We just find it's easier to graph a parabola to find out where it's crossing that x-axis sometimes. Okay, so you're either going to get an and, which is the area in between it. This is an and. Or you're going to get an or. On the outside, it's either bigger than one value or it's smaller than the other. There's no value that's going to be both bigger than a big number and smaller than a smaller number. It just can't happen. So that might be the part that's more confusing. So let's take a look at it. Now, if I have an equation, x squared minus 6x minus 7 is less than 0, there's no y there, I have my options of graphing. Now, I can graph any way I want. I can solve it by graphing. I can solve it by factoring. I can solve it by completing the square. I can solve it by the quadratic formula. Whatever you like, whatever is easiest to you, that's what you plug in and you solve it. Just show me your steps. Show me how you solved it so that I can see what you did and how you got there. That's your communication piece. Your algebra is your communication piece showing why you're right. Okay, so show me those steps. In this case, I'm looking at this 7 and I'm thinking only 1 times 7 makes a 7. This might be factorable. Let's check it. And so if it doesn't, I'm going to go to my quadratic formula. But this is a pretty quick factor if it works. So let's find out. I know x times x makes my x squared. And I know looking at this 7, it's got to be a 1 times 7 that makes a 7. There's no other options. It's a minus 7, so since this is a minus 7, 1's got to be plus, 1's got to be minus. It's the only way I'm going to multiply it and get 2 negatives. And to figure out what I'm looking up here. Now, if that's a negative, then the bigger number has to have that sign, which means the 1 has to be the opposite sign. Now, I'm going to do a double check because this is what I got to know. My inside is a plus 1x, and my outside is a minus 7x. Put those together, you end up with a minus 6x. Is that my middle term? Yes, it is. Okay, good. That means this is factored, and it does factor nice. So that means it is less than 0. Now, you can solve this equation, but easiest way, most of us can look at this and say, well, x plus 1, what would make that equal to 0? And x minus 7, what would make that equal to 0? Some of us can just look at this and say, well, a 1 plus 1, so x would have to equal a negative 1, or x would have to equal a positive 7. Now, here's the deal. I wrote the word or, but it may not be an or. This could be an and. Easiest way, most reliable way of knowing whether you have an and or an or with a minus 1 and positive 7 is to test it on a number line. So on a number line, you've got a negative 1 down here. You've got a 7 somewhere up there. I like testing something in the middle, and the one that I like to test is 0. 0 is my favorite test point. We're going to find out if this 0 satisfies the equation or not. So I'm going to plug in all the way back up to my original equation right up here. I'm going to put in a 0 here. So a 0 squared minus 6 times 0 minus 7. Is it less than 0, yes or no? Well, I know a 0 squared is 0. 6 times 0, that's also 0. A minus 7, is a minus 7 smaller than 0? True or false? Absolutely true. Okay, if that's a true statement, then the 0 that I tested with is a solution. And everything in between is a solution. The last part I want to double check on, in my original equation, did they give me an equal bar? No, they did not. So that means I'm not including the negative 1 and 7. So those are going to be my open circles. I'm going to shade in between. Now, how do I write my answer? Looking at this, I know that I'm shading in between. Because it's an and, I can write the x only once. And I'm going to say that x is bigger than negative 1. And x is also smaller than 7 at the exact same time. And so if it's an and, you write it together kind of like this. Now, what if they would have given us a false statement? What if I would have had minus 7 is greater than, or let's call it equal to 0? Well, in that case, that would be a false statement. So if testing is 0, and I would have gotten a false statement, then on my number line with a -1 and 7, if there's an equal bar, I would have put solid points, completely unrelated of a true or false statement. But if I tested a 0 and I found out I got a false, then it's not the points in between, but it's got to be the ones on the other side. So it's going to be greater than 7 or less than -1. So because it's an or, you have to write it separately. You have to say x is got to be less than or equal to -1, or x would have to be greater than or equal to 7. We don't have a value that's bigger than 7 but smaller than a -1 at the exact same time. There's just no number that does it, so you have to leave it as two separates. So that's just a reminder between and ors. Hopefully this helps. Good luck. Again, let me know if you have questions. Have a great day.